Hi everyone, good morning. So I hope you're able to hear me.
Morning,
Yes,
Bhaskar.
good morning, Bhaskar.
Very good morning. Okay, so I hope I have given some use cases. Did you get a chance to look into that?
Yes, Oscar.
Okay, so you don't have any problem, right?
No.
Perfect. Anyone else?
No, I don't get a chance to explore. So maybe today I'll
Okay.
explore it.
Okay, no worries.
Thank you.
Okay, then let's continue the rest of the few more transformations I'm going to touch. But we don't need to have a knowledge on all the transformations. But if you're interested, you can just spend some time. But I don't recommend you to spend more time with the data flow. I always recommend to go with the Databricks. Okay, so let's go to data flow. A new data flow, I'm just going to create it. df underscore derived column. If my business requirement demands to create a new columns, then how we can create it, we'll see. Let me start my cluster. So we already come across few of the functions. If you wanted to write an expression, even we have seen yesterday with filter transformation and with derived column transformation also we have come across it. Okay, so we can write an expressions with the column names, functions, variables, parameters, operators. All these things we can use to write the expression. So derived column transformation also is going to allow you to write an expression to transform your data. And the difference between your filter or conditional split when you compare with derived is this filter and conditional split, they returns either true or false. Either true or false is going to be returned because they are conditions. But when it comes to here, it is apart from this true or false, this can have a capability to return other things also. Okay, so anything that can return by using this derived column transformation. So how do we know there is a derived column transformation? The derived column transformation is how you can identify is when you compare with your source and target. Okay, so let me take this example so that you can understand. If you observe this use case, so forget about this first thing. You just think about I have a employee.csv here, and I'm having a employee underscore hike is the name of the folder. Just try to map these columns. I have an employee number here. I have an employee number. So when you have it directly the same mapping, then we can say it is a direct mapping. The column directly coming from the data source. Without doing any changes, we can take the data from the source column to target column. If we have such kind of columns, then we can say it is a direct mapping. And ename also is a direct mapping. Job is also direct mapping. MGR also is direct mapping. Okay, so hire date is direct mapping. Salary also is direct mapping. Commission is a direct mapping. Department number is direct mapping. But when you see here, this hike is not coming from the source. Hike is not coming from the source. You have to define that. Okay, so if this column is getting the data indirectly from the data source, then we can say it is an indirect mapping. We can say that is a indirect mapping. Okay, so sometimes even when there is a direct mapping, the data types may also require to change it, but still that we can treat that as a direct mapping. But when you see here, it is completely indirectly coming. Okay, so the hike is not directly coming from the source, it is coming indirectly. So that kind of columns we can say indirect mapping. So this is also you have to do at the time of understanding of your requirement. You need to analyze it. So analysis of the requirement is very important. Okay, so how I usually do it, we'll talk about it when the time comes. So if some requirement comes to me, what steps I used to take it. It's all depends person to person. It may varies. Slight changes they may go, but most of the things will be common. Okay, so in this particular case, this hike is not coming from the source. Then you can feel that you have to define this particular column. This column, we need to define it. Now the question is to define this, what is the definition? You cannot define by yourself. You have to define by business definition. You have to define this by your business definition. So you need to understand the business requirement. Definitely you will be having a requirement document. And if you're not having it, you can just check with the business analyst and they are going to give the answer to you. Okay, so even if they don't have, they will check with the business and they will come back to you. So here the definition for this hike is, it's a just generic I just given here. So here my intention is how we can define the column, how you can understand there is a data deriving. The process of defining this column, we can call it as a data deriving. You're deriving the new data points. So create a data flow to move data from source to target. Make sure to load the data as per the business requirement. Here I have given, if the employee is working in the department number 10, then give 10% hike. If the employee is working in the department number 20, then give the 20% hike. Else give the 30% hike. Okay, so most of us know known definition it is. So how we can do it? Okay, so it's a conditional based calculation. We have a conditional based calculation. So two different types of expressions we can write it. One is with if we can go, another is we can go with case we can go. So case, or we can call it as a switch. Okay, so in some places we can call it as a switch, and some places we can call it as a case. Case statement or switch statement, more or less same. Okay, I hope everyone with me.
Yes, boss.
Okay, so let's do the implementation. My cluster is also up and running. Let's add a source. The source is SRC employee. Let's go for inline. Take a delimited text. Let's take a ADLS. Options and browse the file. Data files. Inside input, I have a file called employee.csv. My first row is having a header. Let's go to the projection and import the schema. Now you can see the data types also all good. Okay, so in this place, if I wanted to change this to short, I can change it. And commission also, I'm just going to make this as a double. That's all. So if any of the data type is not coming accurately, then you can specify accordingly. And I'm just going to say close. And then I'm going to derive that column. Let's take a derived column transformation. So it's a schema modifier because as we are going to add a new column, then it is coming. So the new column, I'm just saying hike. Expression, let's go to the expression builder. So we have a function called if function. Okay, so if style is there something like this, IIF. In some places, if you go for activity level, we have seen the function with just IF. Okay, so same function if you are having experience with SSRS, in SSRS also we have IIF. Okay, so it's all depends. And the place to place they are giving it different, but the intention of this function is very much similar. Here you have to specify the condition. So this condition is always going to return. This condition is always going to return either true or false. Either true or false. So if it is true, if this condition returns true, then this block will be executed. If the condition returns false, then false block will be executed. As simple as that, we already come across the if function. Now I'm saying here, if employee is working in the department number 10. So department number 10, then I wanted to give a 10% of the hike. So just observe how I'm going to write it. DPT number equals to 10. I think DPT number or department number. Department number. So if department number equals to 10, then I wanted to give a 10% of hike. Then here, if it is true, then 0.1 multiplied by your salary. 0.1 multiplied by salary. If this condition is failed, then again I need to check one more condition. I need to check one more condition. So what I'm trying to do in this particular place is that okay. So what I'm trying to do here is, if this condition is failed, let's say for example, department number 20 is coming from input, then it will check 20 equal to 10, then condition is failed. If the condition is failed, then this block will be executed. So here again, I need to check one more condition because there are three conditions are there, 10, 20 and 30. So these three conditions I need to check. One if is there. So when you have a n number of conditions, then n minus 1 if functions are required. So two if functions are required, not only one if function. So here I'm just going to write one more if, IIF. So condition is department number equals to 10, sorry, 20. Then 0.2 multiplied by salary. In the else block, I'm going to say 0.3 multiplied by salary. Okay. Is everyone with me?
Yeah.
Yeah, Bhaskar.
Okay, perfect then. So let me hit on save and finish. So if inside if we are writing. Okay, so just for making you clear, I'm just creating one more new column with the same definition. Hike 2. So this time I'm just going to explain how we can do it with the help of case function. Instead of writing if inside if, or if you have a multiple conditions, then you have to write multiple if statements. So to avoid that, we can use the case function. Case. A department number equals to 10. Then my return value is 0.1 multiplied by salary. If department number equals to 20, then 0.2 multiplied by salary. Else 0.3 multiplied by salary. So this is equivalent to switch statement or case statement in SQL. Okay, so if this is satisfied, then this will be written. If this is satisfied, this will be written. Let's say you are getting 30 department employee. So this will check 30 equal to 10, this condition is failed, and then it will go to the next condition, 30 equal to 20, this is also failed. So finally it will go to this place, 30% of the hike. And if you are getting 20th department, then 20 equal to 10, condition is failed, and then 20 equal to 20, condition is succeeded, then it is going to get the 20%. Okay, you are clear on this, right? Case function also. Let me hit and save and finish and close this. So both are going to give the same result. You can just see here, hike 1 and hike 2, both are giving the same result. Now let me go and take a sync. A delimited text. Let's go to the settings. Data files. Output, inside output, I'm just going to say employee underscore hike. And first as a header, and just leave everything default. I'm just going to create a new pipeline. PL underscore derived. Let's drag and drop your data flow activity and call your data flow. Let's save all. Let's debug it. Any question as of now? Okay, then can you try to do this one?
Yeah.
Okay, so my intention is how you can create a columns. That is the main intention. Okay, so in various places we're going to see different kind of definitions you may have it. So you need to understand the definition. If you're interested to do with the data flow, you can do it. That is, you can understand the requirement. So here I just gave some few columns here. You can just try. Year is there, semester is there, quarter and month.
There might be some functions you
Yes.
can use.
Yes. Okay, just try. If I gave my expectation of year is 4 digits of the year. Okay, so year something like you have to get 2025. And semester something like H1, comma H2. And quarter Q1, Q2, Q3, and Q4. And month, I need 3 characters of the month, Jan, Feb, and so on. Okay.
Sure.
So this is expectation. And other also you can try. So there is a salary plus commission is available. So I wanted to get a gross that is salary plus commission. Just try and validate the data. When you're doing something, you have to cross verify is that matching with your definitions or not. Okay. Let me check. Now it is completed. Let's go and see your data files. Output, employee underscore hike. And if you open this file, then you can see the data. Okay. So here I'm not caring about the positions. Basically, this one I'm just keeping. I wanted to keep after commission. Okay, so or after salary. If I wanted to keep it, then you have to bring it here. So I'll come to that point if I wanted to change the position of the columns. Maybe might be next transformation it is. Yeah, it is the next one only. So if you want to change the positions of the columns, or if you wanted to rename the columns, or if you want to restrict the number of columns, then we are going to use the transformation called select transformation. So this is also very, very important transformation. Okay, so with respect to data flow, but I feel this is much more important in the Databricks. Here you're having a UI, but in the Databricks, we are just going to have a code only. We're going to write a function called select statement or select function. So you can see the purpose of the select function when we come across the Databricks. The same to same is available even in the data factory also. So by using this select transformation, we can do 3 operations. One is selecting only required columns. If my source is having hundreds of columns, if I have a database as a source, then I can write a select statement, then I can restrict the number of columns. Just imagine if my source is a file system. If source is a file system, then definitely you have to restrict the number of columns right after the source. Right after the source, you need to keep the select transformation to restrict the number of columns, so that we can reduce the flow of the data. And renaming of the columns, this is also is important, especially when you go for SCD types implementations, then you're going to have this. And reordering the columns, I mean to say reordering means you're changing the positions of the columns. Okay, so in that case also, you're going to use the select transformation. Okay, so let me walk you through this particular use case, then you can understand. Before going to that, there is a one more use case also I have given for your derived column transformation. You can see here, create a data flow to show the employee names in lowercase characters. If the name is having less than 5 characters, there is a employee name is there, right? So if any of the employee name characters is having less than 5 characters, let's say there is a employee called Word. So Word is having 4 characters. I wanted to convert that into lowercase characters. So if anyone is having more than 5 characters, then convert that into uppercase. Just try. So in this case, we don't need to we don't need to create a new column. You can just replace that values to the existed column itself. Okay, so you can just take a replace, then it is going to be replaced. Just try from your side. And create a data flow to load the data into the target with the required columns. So just observe, I'm just trying to keep this as many, I'm just trying to show all these three different possibilities here. Just observe the same employee.csv I'm having. And let's take a same employee hike, or I think it is a typo. We can take it as a select here. Employee underscore select. And employee number is directly coming from the source. I don't have any problem. Employee name also is coming, but the name of the column is different. In the target, the name of the column is different. So this is going to help you to rename the column. Rename column. And job is coming directly from here to here. And department number also is coming directly. And salary is also coming directly. But if you clearly observe here, one is you're taking only limited columns. Taking limited columns. So one operation is covering. The second operation is renaming column. So that is also is covering. And ordering the columns, reordering. Because you can see the salary is there right after the department number. Okay, so I'm just going to show you all these three together in one shot. So employee.csv, we are going to have it. Let me show you how we can do it. So I can clone my derived column transformation. Let's say select. So I don't need this one. So I have only source. Now from here, I wanted to take only the required columns, renaming and reordering. Let's take a select transformation here. The select is also going to have a capability to skip the duplicate input columns and output columns. Automatically, it is going to be taken out. So let it be as it is. Especially this is going to be happen when you join the two tables or two data frames, or in this particular case, we can say two tables. So employee number is required. Employee name is required. And job is required. Department number and salary. So rest of the columns, MJR is not required, you can take out it. Hire date is not required, just remove it. And commission is not required, you can take out it. And this column, you can give it alias name as employee name. So that means you can rename the column. And I'm just going to reorder this column. You can just drag and drop into the respected positions. So you can swap the positions by using this select transformation. The same to same field that we are going to do it with Databricks also. That is very, very important. So let's close this. Now let's keep the target. Delimited text. ADLS. Let's go to the settings. Data files. And output. Inside output, I'm going to say employee underscore select. And let's go and create a data flow, pipeline for this. PL underscore select. Just drag and drop your data flow here. Now just debug it. Now it got succeeded, and see your output, employee underscore select. You'll be having only required columns in a specified order. The next transformation is aggregate transformation. So the name itself is saying we can aggregate the data or we can summarize the data, depends on your business requirement. So most of you may be aware of sum function, AVG, min function, max, and count. These are all the aggregate functions. Okay, so all these are going to work with the group by. So aggregation, data aggregation is important wherever you go, especially when we are moving from silver layer to gold layer. What is a silver? What is a gold? We'll talk about it when the time comes, especially in the Databricks. So all data engineering projects are going to follow the medallion architecture. So that is going to be bronze, silver, gold. So when the data is moving from the silver to gold, we are going to apply data aggregation here. Data aggregation we are going to apply because this gold is going to have a fact tables and dimension tables.
Basically, gold is something like used for business intelligence.
Yes, exactly. Okay, so in that particular case, mostly we're going to apply extensively data aggregation. We are going to bring up level data, not leaf level data in this particular place. So with respect to BI, we are going to build this. Okay, so in the same way, if you are doing the data aggregation with Dataflow itself, then you have to use this aggregate transformation. So it is used to summarize the data by using aggregate functions. And when you use aggregate functions or aggregate transformation, make sure to select the group by. So 100% we are going to use the group by because you're not going to have only one single measure. You're going to have a levels. I mean to say the dimensions and facts will be there. So there will be schemas, star schema or snowflake schema. So depends on it, we have to apply the data aggregation. So in this particular case, here my intention is how we can do the data aggregation. Okay, so if it comes to me gold layer, I always recommend to do it with the Databricks itself. If you're interested, you can do it. Whatever we are going to say in the real-time project, I mean to say the way that we are going to apply in the medallion architecture, the same thing you can try with the data flow. But only thing is, definitely the cost will be more even for practice. The data will be little more. And you have to do the transformation from here. It is little more cost. Okay, so if you're ready for that, if you wanted to try once, then you can try for that. Okay, so once this is completed, I'll give one data factory project also. So that will help you to do the transformations in the data flow also. If you're interested, you can do it. Now, create a data flow to load the data into the target as expected. So here also it is a AGGR, and I wanted to apply the aggregation. So job wise total salary, I wanted to see it. Job wise, I wanted to see the total salary. So if that is the case, then how you are going to do it? First, just read the data from the source that you already know it. So one is source is required to point your file, to point the file. And the second is, I required only 2 columns. Just select only 2 columns. And then apply aggregation. So two transformations are required. One is source, that is already, of course, it is a source. And then we required one transformation called select transformation, and then we required aggregate transformation. So 2 transformations are required here in order to do this use case. Let's save all. Interconnect. Okay, so some reason it is not allowing to save. Just renaming back. Okay, maybe it was already published. That's fine. Okay, so instead of wasting the time, let's go and create a new data flow. That is df underscore aggregate. Let's add the source, src employee. Let's take a delimited text, ADLS, data files, input, employee.csv. First as a header, go to projection, import the schema. Let's close this one. Now I wanted to take the select transformation to take only required columns. So I don't need employee number, employee name. I need a job. MJR is not required. Hire date is not required. Department number, commission is not required. So job and salaries I required. So I'm just keeping only those two columns. Now you can see the data for only two columns. You can see it. And then I'm going to take a aggregate transformation. So group by column I'm taking job, and aggregates I'm just going to take here is. So let me take the salary itself. So here I'm going to write an expression. Sum of salary. Just taking e count. Count of job. Average. So I can use the average directly. Average of ABG or average. ABG of salary. So I wanted to get the min sal. Min of salary. Max. Max. You can write. So like this, you can just have a whatever the aggregations you wanted to apply, you can take it. Mostly you're going to do all these operations only. Let's go to close. So here I'm just showing only one, but I'm just trying to show all the aggregations. So now you can see. Let's give this data to the target. A delimited text. Let's take a ADLS. Settings or data files. Output. Inside output, I wanted to keep employee underscore AGGR. First as a header. Close this. So let me create a pipeline for this. PL underscore aggregate. Just point your data flow. Let me hit on debug. Now, if you go and see your target, you can see. Okay, so that is about that. And then joint transformation. So this joint transformation also is important. So I mean to say, my intention is joints are important. So where you're doing it, joints is out of the boundary for me. You can do the joints in a SQL, and you can do the joints in ADF, and you can also do the joints in PySpark. So when I say PySpark means it is a database. Okay, so wherever you go, joints are very important. Okay, so we are going to have a whatever the joints we're having with respect to data factory, I'm just going to say about them. So how do you know there is a joints? That is the question. How do you know there is a joints? When you see your target table, if data is not coming from a single table, if data is coming from multiple tables, if your business, you can understand that. If data is coming from this table and this table, then you're getting this all this data, then we can say there is a joining. We can say there is a joining. Okay, so in SQL sessions, we are going to talk about it. Okay, so a little more in detail. But in this particular place, I just wanted to say join transformation is used to join the two tables, or basically when you go with this joins 100%, you can join only two tables at one shot. So if you have a n number of tables, then n minus 1 join transformations are required. If I have a 3 tables, then joins are required 3 minus 1 equals to 2. 2 join transformations are required. So that is what I'm giving here. Join transformation is used to combine the data if the data is coming from more than one table. And we can join maximum 2 tables at one shot. And if we have a n number of tables, then there should be n minus 1 join transformations. And if the two tab, when we can go for this particular join transformations in the data factory is, if the two tables, when you have a two tables, table 1 and table 2, if two tables are having a different structure means columns. If the two tables are having a different number of columns and different kind of data, then we can say we are going to use the join transformation. And once you decided to go with the join transformation, make sure there should be common column between the two tables. Common column is required. If you don't have a common column, then you cannot join the two tables. So 100% is in the interview, you're going to be asked about these joins. So mostly they're going to concentrate on the SQL. And if you're skilled enough in the PySpark, they will also ask in a PySpark also. I used to ask both. When I ask something in the SQL, I always used to ask in the PySpark also. So then only they can easily do it if it is a data factory. Okay, so if the person is more aware of this, I recommend to him to take Insight. But at the same time, ADF also is required, but I don't care about these transformations. These transformations are not required. Okay, so if you know the context and the more in detail about these two areas, then that is more enough to get in that particular person. So we have 5 different types of joins in the data factory. One is an inner join. So inner join is used to get only matching records between the two tables. And left outer to get records from first table, I mean to say all records from the left side table and matching records from other side table. So when you see practically, then you can understand. And right outer is quite opposite of your left outer. And full outer to get all records from both of the tables. And cross join to get the cross product of the two tables. Okay, so in one of the interview, they asked, which join will give the more number of records? Which join will give the more number of records? Can anyone guess?
Sorry, Bhaskar, can you repeat? Sorry.
So I have a table 1 is having 5 records. Table 2 is having 4 records.
Hmm.
If I apply inner, right, left,
Can you
and
tell me the
flow,
records what it is?
5 records here.
Mm,
Okay, so there is a common column, you just imagine, and
yeah,
cross.
suppose. Okay.
Common column is there.
Yeah, but what are the values are there? It depends on the value what we will get in the inner join.
That's what I'm saying.
Uh,
Which join will give more number of records?
Cartesian join.
That's what it is. So some people they will ask, there is no use of this particular question basically, I feel, but I was asked this question. Okay, so we are going to get 5 multiplied by 4. 20 records are going to get for this. But rest of them, they don't get 20 records. Max to max 5, 4, or something like that. Okay, so there are few more questions also is there to ask as part of the joins, but at the time of SQL, I'll cover that. So that will be really helpful. And
Yeah,
you have
sometimes
to
we
answer
ask
it.
like there are two tables with ID columns 1100
Yeah, that's
10.
what
Yeah.
we are going to see that.
Uh,
Okay.
and if we add a null also, what would be the
Yeah,
output?
what would be the output? And even
It's more.
I faced recently for one of the student, he asked me 1 1 3 3 2 something like this, and null
Hmm.
null.
Okay.
What is the rank?
So null is a garbage value, so we can't define a rank over
That's
there.
what even I got a doubt.
Uh,
Okay, so I was there behind him.
uh,
So this particular question was asked.
uh,
So we have given the ranks for the numbers, but we just gave a doubt on this nulls. So we hope it will ignore it,
yeah, one one
or it will
three
go for high. Like this is going to be 1, and this is
one
2,
one.
and this is 3, this is 3, and
It
this
will go
is
for the
maybe
dense
4.
rank. Dense rank it will
Of course,
one two
yeah,
three three.
dense rank.
Yeah, but if you go for rank, it would be 1 1 3
Yeah,
and 4 and 5.
yeah. So that interview question is he asked row numbers
Hmm.
and rank
1 2 1.
and dense rank.
So these are the analytical functions now.
Yes. We'll come across this at the time of SQL. I'll check that even null. I'm having a doubt on the null. Maybe if any one of you know about it, you can answer. Okay, shall we see these joins on tomorrow, or can I continue these joins?
Up to it's
To
more
extend.
like a SSIS data flow.
Yeah, that's what I'm saying.
Hmm.
See, Microsoft, they wanted to travel with the data flow. I mean to say SSISP things. Okay, so I feel some transformations is very much similar, like conditional split. So filter
Yeah.
was not there, and derived is there. Select, in place of select, we can use the OLDB source itself to have a required columns, but select is there in Informatica. So join transformation is there, but here we don't need to sort the data. When you go for
Okay.
SSIS,
SSIS. We need to sort it.
before joining, you need to sort it if it is not a database, or if we are not saying that incoming data is a sorted data. So few things I feel very easy here. Okay, then we'll see about this joint transformations on tomorrow. And SCD type 1 also we are going to see how we can implement it. Okay, any question before stopping? So from next week onwards, we're going to start talking about the database. On weekend, I'm going to plan to talk about the SQL. Okay, so
Okay.
in a different time, so that the SQL also will be forward. Most of you know, but if you're interested to attempt, you can attempt it, but it is not a regular time. So on the weekend, I'm going to take it.
Okay.
So Python, I'll talk in the regular sessions, in the regular time. Okay, then we'll see on tomorrow. Thank you for joining.
Thank you.